Okay, another beautiful day. You ready for something new?
Yeah.
Okay, so I optimized the schematic a little bit, yeah? So this is our current boost converter. So what I modify exactly, I added a resistor in the serial with a PWM signal generator, just to be sure in case something bad happen, we are not burning the PWM signal generator, yeah? That's everything. Also, I replace the diode instead of this one. It's no point. This is a 10 amps diode. That's a 5 amps. It's more than enough. The capacitor has been replaced from 330 micro 50 volts has been replaced with 100 micro 400 volts. And also I replaced the coil. So this is a bouncing coil. Yeah, it will bounce more because it has more wire. Yeah. So more wire, the coil, it will bounce back more voltage. Yeah? Good. Let's test it together. You remember last time we checked it was like 400 milliamps and 30 volts, 30 something?
33, I think.
Yeah, let's check now. Let's check now. Just to understand what optimization means, yeah? Good. So I will hold here and you follow the voltage on the screen, yeah? Good. Minus, plus. So I want you to follow the voltage and increase the duty cycle. Okay, so we are like 280 milliamps and we have 60 volts. 70 volts.
Oh.
I can go down back. I set up a current limit on the power supply, yeah. Okay. But I tested quickly and I get like with 60% duty cycle or 70%, I get like 150 volts.
Wow.
Just to understand how this changed just by replacing the coil. Because that's basically what we replace, the coil, and obviously we fit a higher voltage capacitor. Now you can see here, this resistance has a black mark on it. Why? Yeah, check.
It's still even hot?
Yeah, why that happen? Why the resistor is getting burned?
Because he doesn't let the voltage to go to the LED.
But how a
LED.
resistor doesn't let the voltage goes?
Wait, the resistors limit the current, right?
Yes.
Yeah, but the current goes up, the voltage goes up, right?
Yeah. Okay.
So that means it exchange into heat.
It's losing the current.
Yes.
I mean, obviously, here you increase the voltage. You increase the voltage, you increase the output power.
Yeah.
You remember the relationship, yeah?
Yeah.
Volts or amps, and you have the output power?
Yes.
Yeah. So you have to lose this power somewhere.
Yeah.
And you're losing with the resistors, yeah? Resistors limiting the current, right?
Yeah.
But obviously, you go higher in voltage, it will start smoking because those resistors can lose like 0.5 watts, I believe.
But what happened is these resistors got burned completely.
It's getting interrupted.
So
The resistors are not getting shorted ever.
So the voltage doesn't pass.
Yeah, obviously, it's like you cut the wire, same thing.
Oh, okay.
Now we have a problem here. The problem is my LED can get burned if if wrongly I set up the duty cycle higher than it should.
But how that LED get burned if that you said?
Okay, the resistor it will get burned.
Yes.
Yeah, I mean don't get me wrong. If you see this resistor smoking, the current is going higher everywhere. I mean it's going higher across the resistor and across the LED. You understand?
Oh, okay.
That's how it works. Every component it will take the pressure.
Yeah, but
they're in the serial mode.
It's not like only resistors get burned and the LED will be fine. It will get burned as well, right?
If you pass the LED current, because every LED they have a certain current. Not this one. This one is quite a strong one. I think it can take like even 2 amps. But like a normal LED, yeah, like 25 milliamps, you can easily pass that current and you can burn the LED. So what do I want to do today is to limit the voltage, yeah? So I want whatever happened to have like a fixed voltage, no matter the duty cycle. So how we can do something like that?
Oh, let's see.
I want precisely same voltage on the output, no matter how I play with the PWM signal. So what we can add in this schematic to have a constant voltage at the output?
Capacitor?
A capacitor it will not limit anything. A capacitor is getting charged and discharged.
Oh, yeah.
It's a little bit more complicated, yeah?
Is that a Zener diode?
Exactly. How did you know?
Because when we learn about diodes, right?
Yeah.
You said something at some point about the Zener diode.
It will let the current pass
Yes.
on a certain voltage.
Yeah.
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 That's actually fantastic. I didn't expect that for you. And the people probably they don't know, but we are not speaking electronic apart from the videos. Yeah. So I'm surprised. I'm impressed.
Because that one, some people say like, "Oh, she doesn't know anything." Of course, because we are not speaking outside the video about electronics.
Yeah, but don't get me wrong. We cannot use something like that. I mean, you know something, but
Yes.
you ignore the current. Yeah, so you know about okay, it's passing the volt, but what to do with the current? If you have too much current, you'll burn the diode.
Okay.
So you mean a diode? So you said a diode from here, yeah? That's a Zener diode to here. And yeah, on that point, indeed, you'll be at fixed voltage till the moment you have too much current. I mean, if you have higher voltage here, obviously voltage goes up, current goes up, and at some point you will burn the diode. So the diode sender and the parallel with the output can be used on circuits with low current, but not here.
All right.
Indeed, this is a current boost converter. And indeed, you trade the current for the voltage. But, you know, even this current, it will burn the diode. First, let's use a Zener diode because we need something, yeah, to let us know when the voltage pass through, yeah? So we're gonna use a Zener diode around 15 volts. Okay? So we know when the voltage goes over 15 volts, the current it will flow through the diode, right?
Yeah.
So now all what we need is somehow to stop this transistor switching. We cannot alter the PWM signal generator to limit the duty cycle, let's say, yeah? But we can alter the MOSFET. Of course, we cannot stop the MOSFET because here is high current, right? But we can play with the gate. What do you think? Somehow to limit the gate voltage in order to stop the voltage to goes up.
Okay.
Can we do it? So what we can connect on the gate?
The minus from the...
From the diode?
Yeah.
But nothing it will happen. It will, in the moment the 15 volts goes over 15 volts, the voltage it will pass and you will send to the gate 15 volts. That means the MOSFET, it will drive like full power. So somehow you have to inverse that kind of voltage. If you have inverse, let's say, if the voltage goes up and here you get like minus, that makes sense. I can connect it here, and I know the gate it will be switched to ground when the voltage goes up. Huh?
But I don't know where then.
You don't know how to do it. Okay, what about, yeah? So pay attention here. What about we are connecting from here, yeah? We are connecting a MOSFET. Ah,
Another one?
yeah. We are connecting a MOSFET to ground. Channel and MOSFET. So we connect a MOSFET to ground, right? So that means when I will have voltage on the gate, it will short the PW signal to ground. Yeah? If you shorten PW signal to ground, it's same like shorting the ground with the source, right? Because the source is connected to the ground.
Yeah.
Interesting. And now all we have to do, yeah, is to connect the gate to the diode, right? So when the voltage goes over 15, then the voltage comes into the gate, yeah? Having voltage on the gate, the MOSFET, it will drive the power here. It will have like 0 ohms. It will short the gate to ground. So what do you think about this?
Confusing, but
Confusing. You have to tell me what is confusing. You have to tell me what is confusing. We know the MOSFET, it's a switch. It's nothing else. Basically, we are switching the gate signal to ground. So what is confusing?
the thing how the current will go. I'm thinking like how
It will go where? Which current? Just forget about the current. The MOSFET is opened by voltage. So
Yeah.
after 15 volts, the voltage, it will pass the diode. So I will have 15 here. You understand? I will have 15, but I will have 16.
Yeah.
Because the 15 is the moment when the diode start sending the voltage on the other side. So what is confusing? So what you will get on the gate, you will get 15 volts on the gate. And the moment you get on the gate 15 volts, obviously between the source and the gate, yeah?
Yeah.
This MOSFET, it will have 0 ohms. That means it will short this signal. So what is confusing? If you shorten this signal to ground, this MOSFET, it will not do anything.
I don't know, but you messed up everything here in my brain. Like,
But just focus, yeah? Focus.
I feel like you cannot see it. My brain is like smoking.
I know, but just focus on this. Just forget the rest of the schematic. Just
Yeah.
focus on this. So what do I want? I want to switch this signal to ground. Yeah? It's the PWM output, right? Yeah. So how can I switch it to ground? I'm adding a switch. This MOSFET is a switch.
Yeah.
In order for this MOSFET to switch, I have to have in the gate more than 5-6 volts. Yeah? So if 15,
You have 15.
yeah, it's fine.
Yeah.
They are working up to. So what is not clear and what you don't understand, you have to tell me, because if you don't tell me, I can't explain.
I don't know.
So I will slow down by cycle, yeah? Good. So this signal is 1, yeah? It's here. Here is 1. Yeah?
Yeah.
The duty cycle is here. It's up. It's high. Okay, let's say high. High. When this duty cycle is high, that means the voltage on the gate is high. That means my MOSFET, it will charge the coil. So here I will have 0 ohms between the MOSFET pins, and it will charge the coil.
Yeah.
Nothing, it will happen. Then the MOSFET is switching down to low. Okay? When it's switching down to low, that means I will have on the gate 0 volts. The MOSFET, it will not drive the power to ground, so the coil, it will bounce. Yeah?
Yeah.
With the plus here, and the plus, it will go through the diode. At that moment, the voltage is rising. Okay?
Yeah.
The voltage is rising over 15. The diode, it will send the voltage to this MOSFET,
Yeah.
and the MOSFET, it will short the ground to gate. So the next cycle, it will not be a next cycle. It will be still 0. You understand?
Yeah.
Till the moment the voltage goes down. When the voltage goes down, then it will be no voltage on the gate of this MOSFET. Yeah?
Okay.
So you understand? So what you don't understand?
No.
So you think it will work?
I don't know. I don't know. We have to try it, no?
No, you don't
No?
have to try. You have the schematic
Okay.
in your front. You don't have to try it. You have the schematic here. All you have to do is to think how how it will work.
Yeah,
So it will work or not?
it will work.
No, it will not work.
With the why?
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 You forget how you use the MOSFETs. You remember? What did I told you about MOSFETs? You cannot use the MOSFET as a transistor. Always the gate has to be somehow dragged to the ground. Remember I told you? The gate is capacitive.
Okay, but
Remember I told you you have to have a resistor between the gate and source. Remember?
mm-hmm.
So we need a resistor from here to ground. Okay? Just to be sure, let's say here it is low voltage and the voltage is not passing the diode. My gate will be floating. And a floating gate on a MOSFET means 0 ohms across the MOSFET. You understand?
no, but
Why
No.
this doesn't have resistance?
yes.
Because the PWM, it will do this job. Yeah, it's switching from 0 to 1.
Oh, okay.
Yeah?
I was like, why that gate is not
Yeah.
connected to the ground?
Yeah, that's why. Because the PWM is moving the signal from 0 to 1. 0 means ground, 1 means high.
Yeah, but if you put the resistor there,
Yes?
you will still have the 15 volt on the gate?
Yeah, we are using a higher resistance, like 3-4 kilo ohms. You know
Oh.
what I mean?
Mm-hmm.
It all goes like just few microamps will be the current going through the resistor, so it will change nothing on this functionality.
Mm-hmm.
But I know when the voltage is lower and the voltage it will not pass the Zener diode, yeah,
Mm-hmm.
my gate it will be dragged to ground.
Okay.
Yeah?
Yeah.
So we should do it?
Yeah.
Yeah, let's do it. Let's do it. Let's do it. Let's do it. So what do we need? We need to disconnect this. Yeah, I'll give you a Zener diode. Give me 1 second.
You have to give me a Zener diode, you have to give me a MOSFET, and you have to give me
MOSFET, Zener diode. Yeah, a MOSFET.
a MOSFET and a resistor.
Yeah. Zener diode will have the transistor, and we have a resistor, right?
The transistor, the MOSFET. Transistor.
Yeah, the
Three
MOSFET
legs.
is a transistor.
Yeah, 3 legs transistor. Oh, look, we can use this one. So, transistor, 3 legs,
Yeah, it's a MOSFET.
a MOSFET.
Okay, you know the legs of that MOSFET?
No.
I don't know either.
No.
So first you have to see what MOSFET it is. Then we are checking on the internet the datasheet of this MOSFET.
Okay, and we find out which one is the...
Yes, yes,
All right. We have the resistor and
Yeah.
we have the Zener diode.
yes,
Okay. Zener diode. This is plus.
yeah.
Okay. Good. This one is, it says 2N7000.
The 2N7000, let's check. Okay, so that's your MOSFET. Check here.
Yeah. 2 is the gate. I mean, the middle one.
Yeah, is the gate. Yeah, that's easy.
Yeah. So that's the gate. The left one
Yeah,
is the source, and this one is the drain.
yeah.
All right.
Now check here the specification. It's another thing which is important. It's a channel N MOSFET, yeah?
Mm-hmm.
Drain to source voltage, yeah? Max is 60 volts, okay? So it's fine in our project. Drain current,
It's 200 milliamps.
yeah, we don't really care because we are speaking here about voltage, no current, yeah?
Mm-hmm.
Gate threshold voltage, and that's important, 3 volts, yeah? So starting from 3 volts, your MOSFET start driving current.
Current.
Yeah.
Mm-hmm.
Then max voltage gate source voltage is 20. So we are using 15, right?
Mm-hmm.
So should be fine.
Yeah. Mm-hmm.
Okay. So all fine with the pins.
Source, source drain. Yeah.
So take the solder iron and let's do it.
Give me the schematic first to see.
It's on the screen.
It was. Give me 1 second. And
The gate has to be with the drain. I don't think that's the drain. You sure that's the drain pin?
this one?
No.
No.
From this MOSFET.
No, this is the drain. Yes, this is the drain.
You see?
Yeah, this is the drain.
So you are about to do a mistake. So on the gate has to be soldered the drain, yeah?
Yeah.
Yeah, do it.
Yeah, but wait a second. And the other one
Yeah?
should be like this.
We can use a wire for that. It's risky to
Yeah.
connect the
but-
transistor over the diode. Yeah, yeah.
So I should put it like this?
Yeah. Good. Now solder the diode.
The diode.
Yeah?
The Zener diode.
Yeah, the center diode.
Oh, give me the schematic.
Yeah, it's here.
No, this one.
Oh, sorry.
Right. The Zener diode must be
From where is solder?
from the capacitor.
Output, capacitor, diode, you know, from the output, yeah, to the gate. Right?
Yeah. So wait a second.
Yeah, I'm waiting.
This one.
Yeah?
This is the plus.
Yeah? You see, the electronics is beautiful. When you understand, you can do anything what you want. I mean, we can do this small circuit to do whatever we want.
All right. To the
Gate,
gate of
the MOSFET, yeah.
This one.
Yeah. Good.
Okay.
Now the last pin, you need a wire to connect it to ground, right?
Yeah.
Yeah, you can use this
Yeah,
one.
but we put wires again.
Yeah, but you don't have a higher current flow here.
Okay.
You know what I mean?
Yeah. So we connect
Yeah.
this one
Yes.
to the
Yeah.
good. To this.
No,
No,
check the
wait.
schematic.
Wait. That's the source.
Yeah.
Oh, we need to connect it here
Yes. Yeah. To ground.
to ground. Yes.
Good. So all is left is the resistor.
Yeah. The resistors goes from
From,
from ground
yeah.
to the minus.
From what? The ground is the minus.
Ground is from this one. No, wait. No, we have to be between those here. Like between this one and this one.
Yeah, but try to imagine the resistor here. It's same thing. So the resistor is between gate, yeah, and source, right? Check here.
Yeah.
Or between gate and ground. I mean, it's same thing. It's same track. You know what I mean?
Yeah.
You can place it anywhere.
I mean, yeah.
Okay, let's do it.
Let me make it shorter.
Okay. All good?
I think so.
It's solid?
Yeah. Don't laugh about my creation.
Yeah, it is solid. So it's time for testing, right? Yeah, let's
Yeah.
do it. Let's do it. So we have minus. We have plus.
Mm-hmm.
Minus and plus. And
Yeah.
I will check the output voltage for you.
Mm-hmm.
Let's see if it's working. So we have 11.8. Go up. So So the voltage is going up to 16. You see you have 40% duty cycle right now.
Yeah, 50 now.
And the voltage is stable. Yeah, go up. 16%. 60% duty cycle.
Yeah.
Go up.
74.
So you understand the voltage is the same. It's not changing.
Yeah.
80%. So you see,
Okay.
you have exactly the same voltage.
Yeah.
So this is a current boost converter, voltage regulated. You understand?
Mm-hmm.
The voltage is the same.
Yeah.
Okay, let's check with the oscilloscope because you will understand better. Okay, so here is the gate of the MOSFET. Yeah, I can check
Yeah.
here. I can check here.
Mhm.
So increase the duty cycle. Yeah, we can see it here. Yeah, go up.
Oh, too much?
80 something. You can.
79.
Yeah, it's okay. It's fine. Yeah. So that's your signal. You understand?
Mm-hmm.
Now go down. You see the signal is the same.
Yeah.
You can see? Go
Even
down.
63, 50.
Yeah, now it's changing. Yeah, now it's changing because you got like,
Yeah, too much.
yeah. So the signal basically is the same, yeah?
Mhm.
Now let's check before this resistor, yeah? So we have this resistor in the serial mode with the gate, yeah?
Yeah.
So check the signal
Oh,
here.
wow.
Now change the signal,
More?
yeah? So you can see the duty cycle is changing,
Yeah.
but not here. Here is the same. Now go down, 70, 60, 50, you can see?
Yeah.
40, 28, yeah? So you understand what is happening. So basically, even if you come here, this is delivering different duty cycle.
Mm-hmm.
This transistor is switching ground, whatever is extra, you know, even if you push more duty cycle, the
Yeah.
transistor, it will switch to ground, whatever is extra. That's why it's not changing here.
Yeah.
You understand? So whenever, yeah, voltage goes up, this it will cut down the duty cycle, no matter what duty cycle you will have here.
Mm-hmm.
Hmm?
Yeah.
So how do we know this circuit is actually voltage regulated? I want to be sure, you know, it will keep a constant voltage even if I'm playing with the current at the output. So let's try something, yeah?
Mm-hmm.
Let me disconnect the output load, yeah? We have the LED, it's a load, right?
Yeah.
Yeah, let's do it. Wait, the solder back. So we disconnect the load, yeah?
Mm-hmm.
Let's check together, yeah? So hold it here. Check the signal, yeah? Now I'm connecting the load. Yeah? So check here how it's changing the on-off period on the MOSFET. You can see?
Mm-hmm.
You can see the duty
Yes.
cycle actually is changing based on a load.
Yeah.
Let's say I'm using more current. 1 second, I will connect here.
Oh.
You can see how
Yeah.
the duty cycle is changing.
Yeah.
Even if you don't change it, but
Mhm.
it is changing. But you understand?
Yeah.
We are regulating, this circuit is regulated by the voltage, yeah?
Mhm.
So the voltage is making the rules on this circuit, yeah?
Yeah.
So no matter what signal you have on the input of the MOSFET, always, based on the output, the circuit it will be regulated by the voltage, yeah. So you understand? That's how you make this kind of switching power supply constant voltage. So now you can use, we know for sure here we have like 16 volts, right? And we can use it being sure always will be the same voltage.
Yeah.
Yeah? I mean, let me show you something more interesting, yeah? One second. Let's solder back the LED. So we solder back the LED. What it will happen if we are dropping the voltage? Let's say, okay, on your house it's a voltage drop. You use this circuit and it's a voltage drop.
But depends for how long, because that capacitor, it will...
Yeah, but let's say it's dropping from 12 volts to, let's say, 8 volts or 5 volts. What do you think it will happen? What it will happen with the voltage? So what do we have on the output?
It was 16 something?
Yeah, 16.6.
Yeah.
Let's imagine, yeah, because you think right now, okay, the volt, even if I increase the duty cycle, the voltage is like a fixed voltage on the output, yeah?
Yeah.
Let's change the input voltage. The input, we have 12 volts, right?
Yeah.
Okay, let's go down 10 volts. How is the output? It's still 16
Still
point
16,
something.
yes.
Yeah. Let's go down 8 volts. It's still same output voltage.
Yes.
Okay, let's go down. Let's see how long. Nah, we can we can go down to 7 volts. So you understand?
It's like nearly half.
Yeah, like nearly half. So the circuit is still trying to keep up that voltage
same,
which is
yeah.
set up by the Zener diode. Yeah?
Yeah.
So what the circuit it will do? How it will keep up the output voltage?
How? Yeah, that
Your transistor is increasing the duty cycle. You didn't touch that one.
yes, I did.
You understand?
Uh-huh.
Let's check it. Let's see indeed. So that's the duty cycle. So
Yeah.
if we are increasing the voltage, what it will happen?
The duty cycle, it will change.
Okay, so it's still 16.4, yeah? So check here what happened, yeah, with the duty cycle when I'm increasing the voltage.
Oh, well, it's changing, yeah.
Yeah, you can see? Look. So from larger duty cycle, it's getting slimmer, you can see?
Yeah.
Even if you don't touch the duty cycle on the PWM generator.
So that's because of the MOSFET.
Yeah. So it's not only regulating the output voltage based on what you come in, like the PWM, yeah?
But it's regulated the duty
Even the
cycle.
input voltage.
Yeah. That's interesting.
Cool?
Yeah.
So that's how voltage regulated power supply are working. The electronic is cool or not?
It's cool.
Well,
yeah.
is something what you don't understand?
No, I understand. I'm trying to,
How to process? You process
proce-
later?
no, to stack all the information in my brain.
If you think this is cool,
It's something else that
next
is
time
more cooler.
we're gonna learn about current control, switching power supply. Yeah,
Okay.
maybe I want constant current. You need for something you need constant current. If, for example, charging the batteries. Yeah, on the batteries you don't charge constant voltage, you charge with constant current.
But what do you need for the constant current then?
We're gonna see
'Cause
next time.
I think it's something else than Zener diode and transistor.
We're gonna see next time. Yeah.
Okay.
Okay.